ProfessorBlackOps, cybersecurity for the people. We're going to go over Tomcat server security view. Tomcat actually is used more for a Java container and running Java code. So we're going to actually go over the security checks for actually Tomcat. Of course, we're going to go through it in AWS. Beanstalk is actually AWS version of Java. It has embedded Tomcat in there. So we actually talk about that. So if we're going to run Elastic Beanstalk, an AWS service on AWS, we still want to make sure we're secure by running these checks in that Beanstalk. In a later video, I'm actually going to do that. Actually put those checks in AWS on Beanstalk and actually run a Java application. So this should be a short video. Once again, we're just going to go over Tomcat server, the security review. So this is what I usually start off with. This is the AWS networking. So if you see the blue, that's the database, and right in front of that is the application server private segment. That's actually where our Tomcat would run. Right here. That would be on a private network, so you couldn't be able to actually get it from the internet. So once again, this is the a higher level view. The application server is right here, right in front of the databases. Here, Tomcat will run. You will run your Java code right here. So as the user comes in, touch your web server, that will be IIS or Apache. It will go through your load balancer right here. It would actually get to your Tomcat server or your IIS running your application code, and will actually access your database. So that's where it will run. It's pretty small, but it does say application server. So Apache Tomcat, called Tomcat for short, is an open source implementation of a Java servlet, Java service page, Java expression language, and WebSocket technology. Tomcat provides a pure HTTP web server environment in which Java code can run. Tomcat is developed and maintained by an open source community of developers under the auspice of Apache Software Foundation, released under Apache License 2.0. So once again, it's open source, it's free. It's probably the most used Java container for Java development. This is Elastic Beanstalk, is the application security server by AWS. AWS Elastic Beanstalk is easy to use service, deploying and scaling web application servers developed with Java. That's why I'm using for .NET. PHP, shout out to Keep It Techie. I saw his PHP development, so I'm also going to work on my PHP. Node.js, Python, Ruby, Go, Docker on a familiar server such as Apache, Nginx, Passenger, and IIS. You can simply upload your code to Elastic Beanstalk. Automatically handles deployment from capacity provisioning, load balancing, auto scaling to application health monitoring. At the same time, you retain full control of the AWS resource powering your application and can access the underlying resource anytime. There is no additional charge for Elastic Beanstalk. You pay only for the AWS resources needed to store and run your application. So that's why Elastic Beanstalk is pretty popular. Once again, like we're going to talk about the Java feature, and the Java container underneath it runs as a Tomcat, Apache Tomcat. So we're going to go over the changes you need to secure that Apache Tomcat in that environment. So we're going to start going over a few of the high-level checks. Of course, all these checks will be in the description box along with links. So that's the vulnerability. That's the code. It's a high-level check. Default passwords on keystore must be changed. Tomcat currently operates only JKS, PKS format keystores. The JKS format Java store is a standard key store format and is format created by the key tool command line, which include JDK. It manages using OpenSSL or Microsoft Key Manager. Requirement only applies to JK keystore. Is created if a password is not specified during the creation of the default password used by Tomcat. Is change it, all lowercase. If the default password is not changed, the keystore is at risk. So basically, you want to change your default password on your Java keystore. This is high. The TLS must be enabled on JMX. JMX is Java Management Extension. It provides the means for enterprise to remotely manage the Java VM and can be used in place of a local manager application that comes with Tomcat. The management tasks such as monitoring, control of applications is accomplished via MX to JMX remote servlet. If authentication is disabled, an attacker only needs to know the port in order to manage and control your hosted Java application. The authentication needs to be able, basically, using a password key to log on. If not, some random bad actor could take control of your Java application. If you're using an LDAP authentication, it must be secure. The GNDI RAM is an implementation of Tomcat RAM interface. It uses JNDI to look up the LDAP directory server. The RAM connection to the directory is defined by the connection URL, configuration attributes. This attribute is an LDAP URL that specifies the domain name and directory. This can lead to authentication credentials being transmitted across the network connection in clear text. So basically, they want to make sure you're using TLX or SSL. If you use an LDAP to authenticate your Java application, a lot of people use LDAP because Active Directory and Microsoft is an LDAP. So a lot of Java applications actually use that to actually authenticate their apps. They just want to make sure any connections to that's in the clear so nobody can do a man-in-the-middle attack. The Tomcat must use FIPS-validated cipher on a secure connection. Connectors are how Tomcat receives requests over the network ports, pass them to the host base via HTTP or HTTPS, then sends the results back to the requester. The cryptographic ciphers are associated with the connectors to connect to the secure connector. To ensure encryption strength is adequately maintained, the ciphers must be FIPS-140-2 validated. So at the beginning of my slides, I actually have FIPS-140-2. That basically means the encryption has been sent out to the government. The government actually looked at it and validated that it was actually using the encryption ciphers correctly. The most ones we use are AES-256. Those are the most secure. Once again, FIPS-140-2 validated means it was actually sent to the government and was approved to be actually working correctly. The AccessLogValve must be configured in each application. Tomcat has the ability to host multiple context application on one physical server. This allows admin to specify audit settings per application. So if you are using Tomcat and you're running multiple applications, they just want to make sure you're actually logging your applications individually to their logs so you can actually view the logs and see what's happening on the application. If you don't do that and you have 5 applications running on one Tomcat server, all those error logs will be in one file. So they just want you to separate them out so they'll be easily deciphered. And 2 is you don't want certain admins of one application being able to look at errors in the other application, right? You want those to be kept separately. They could be different security levels, different security groups. One could be HIPAA, which is health. One could be PCI, which is credit cards. So you definitely don't want to commingle those logs in one log. Cookies must have a secure flag set. It's possible to steal and manipulate web application session cookies without having a secure cookie. Configuring the secure flag inject settings in the response header. Allowing the cookie to be only viewed by the application that's supposed to be seeing. So if you go on the Catalina base directory and you config in a web XML, you can set your cookie flag in there. The connectors must be secured. Unencrypted HTTP protocol does not protect data from interception or alteration, which can be subject to eavesdropping, tracking, and modification of received data. To secure an HTTP connector, Both must be secure and the scheme flag must be set. So once again, if you're using Tomcat as a HTTP server, you just want to have HTTPS enabled, so all sessions and traffic on that container is encrypted. A lot of times people use Tomcat as an application server, but in the front they use Nginx or an Apache. So they do all the encryption at the front end web server, then pass that connection on to the application server, which would be Tomcat. So the Java Security Manager must be enabled. It's what protects the Tomcat from Trojan servlets, JSP beans, tag libraries, or even from advent mistakes. The JSM works the same way as a client web browser isolates a running web application via sandbox. The difference is the sandbox is running on the server rather than the client. To ensure the application portability, JMS security policy must be set to allow the hosted application. So the JSM security manager, you put rights actually on your Java application from an application server standpoint. What protocols you're accepting, who logs in, who can do what. So that's why they want the Java Server Manager enabled. Clusters must operate on a trusted network. Operating a Java cluster on an untrusted network creates potential for an unauthorized person to view or manipulate the cluster session traffic. When operating a Tomcat cluster, care must be taken to isolate the cluster traffic from an untrusted source. Operation includes using a private VLAN, VPN, IPsec tunnel, or by encrypting cluster traffic by using an encrypted interceptor valve inside the Tomcat web XML itself. So if you're using cluster, usually you have 3 Tomcats running at one time. There's a virtual Tomcat sits on top. So if one of those clusters goes down to the 3, the other 2 will keep working, right? Because you always want high availability. So on that cluster, as the cluster, those Tomcats are going to talk to each other. So you want all that traffic as they communicate between each other encrypted. So one reason we do these type of security checks are so we can be validated for any of the compliance. We have some of the top compliance checks that we're trying to get approved for when we do these type of checks are HIPAA, which is for health and hospital, for hospital work. PCI is for credit cards. FISMA is usually for government installation. FedRAMP is for government installations in the cloud. So if you talk about Azure, AWS, or Google, all those have their FedRAMP certifications. Then one I've been working closely with and has been for years is publication IRS 1070. The IRS has their security checks they need to do for your particular application. Once again, ProfessorBlackOps, cybersecurity for the people. We went over Tomcat application security checks. Thank you very much.